Okay, so let's solve this problem. So this problem actually came this year JEE Advanced paper 1. So first read the question very carefully. So what it states, it's following that a point source S which emits an unpolarized light. Be careful. That is basically which is uniformly spread in all directions, right? So now let's say 2 point A and B, the ratio of their intensity IA over IB is 2. Fine. Now if we place two polaroid having angle 45 degree in between them, then placed just before the point B, then what is the value of R? Correct. So now let's say this is the point S, and from there this is the, let's say, point A, and this is the, let's say, point B, point A and point B. And what is given? So given is following. So given is IA over IB is 2. So now if we uh, place two polaroids in the ray of in the line of B, so this is the tentative diagram that we supposed to follow for the second setup. Now the question is, what does this polarizer do for an unpolarized light? So first polarizer, for example, this, let's say, this polarizer P1, and this basically, let's say, called P2. Okay, so what P1 does is basically it determines the axis of polarization of light. So now what we know from the electromagnetic theory, that for example, if this is the axis of oscillation of electric field, and this is the oscillation of, let's say, magnetic field, and that x-axis is actually the uh, x-axis is actually the direction of propagation of light. What happened in the unpolarized case, that electric field that we wrote here along the y-axis is basically when the light is polarized along the y-axis. However, for an unpolarized light, what happened, that electric field can polarize in any direction in the yz plane. So yz plane. So once you pass through this unpolarized light through the polarizer, then what it does is basically determine the angle of or the axis of polarization, right? So now initially the IB is basically an unpolarized light. Now when it's passed through this first polarizer, so I0 is the polarized light, so therefore the intensity of I0 is basically the IB over 2. And this 2 factor actually coming from, so initially the electric field for unpolarized light can oscillate in any direction. So when it passes through this particular polarizer, so then what happened, the component along this axis, so therefore the we have the intensity is actually proportional to cos square theta. So theta could be like any angle from 0 to 2 pi. Now for an polarized light, we have to take the average of this quantity from 0 to 2 pi, and divided by 1 over 2 pi. So that's the averaging, right? So now if you do this small integration, so that you will get like this is actually the answer is half. Okay, very good. So now when this polarized light I naught pass through the second polarizer P2, so what would be the intensity of after polarizing through the second polarizer? That we call, let's say, IB prime. So now we have to use the famous Mellor's law. So what it states, that when an polarized light pass through and the second polarizer, so that's the intensity after the second polarizer is basically proportional to the cos square theta. The theta is basically angle between the axis of polarization from the first polarizer and the second polarizer. So the Mellor's law states is basically the intensity, so IB prime is equal to I0 cos square theta. Okay, so now therefore the IB prime is equal to I0, and that is basically the cos square 45 degree. So that would be like IB by 2, and cos square 45 degree is basically the 1 over root 2 square. So it's basically the IB divided by 4. Okay, so now the new R, so the new R would be I a prime divided by IB prime. So IA prime is same as the IA because we don't change anything from in the line of A, where B is has some modification according to questions. So basically IA is basically IA prime is basically IA, and the IB prime for TC is basically the IB by 4. So that is basically the 4 times IA over IB. So that's basically this quantity is we know from the initial given information. So that would be like 4 times 2, so that would be like 8. So the final answer would be like 8. Okay, so that's it. So that's the question. So now let's understand few points from this question. So what happened if the second polarizer is placed with respect to first one not by 45 degrees, let's say by 90 degrees. So if it is 90 degrees, then we know that cos square, so I just okay, so let's say the second polarizer set with respect to the first one is 90 degree. So if it is 90 degree, we know that cos square, so the intensity is basically the proportional to cos square theta. So cos square 90 degree, so cos square 90 degree is basically what is 0. So if the second polarizer placed at an angle 90 degree, so we don't see any light after passing through the second polarizer. So basically your IB prime is equal to 0. Very good. So just to think about a bit more. So let's say you have, instead of 2 polarizer, if you are, let's say, using the third one. So what third one does is basically, so let's set the same setup. So so initially the first one is actually did the usual polarization. Second one basically placed, for example, at an angle 45 degree, and let's say we place the third one. Okay, so when we place the third one, so third one actually making a 45 degree angle with respect to the second one, not the this case. Okay, so but if you see that the third one actually making a 90 degree angle with respect to first one. So what happened in that case, the second case, when you have the 3 polarizer, so we know the IB prime. So IB prime is basically the IB, so I0 over IB over 2, that's basically the I0, and the cos square 45 degree, that would be like earlier we calculate, that is 2, so that would be like IB over 4, right? So now that IB over 4 would be the incident light with respect to the for the P3 polarizer 3. So in that case, what happened, your IB double prime would be IB prime, and then cos square, so in that case is again 45 degree, because this P3 making 45 degree with respect to P2, so that would be like, this is again half, and then your IB is prime is basically IB over 4 times, that would be half, so that would be like IB over 8. See, so the earlier case, when you have 2 polarizer, so the second one makes the 90 degree with respect to first one, so the IB prime is 0. However, when you have the third one, but effectively the third polarizer 3 makes a 90 degree with respect to P, but instead there is in between P2, which is making the 45 degree with respect to P1. So in that case, the intensity goes down by factor of half, but not 0 for the second case. Okay, good. So now if you understand this Mela's law a bit more, so let's stick to one more point. So what should be the behavioral study of the intensity after being polarized through the second polarizer? So what we see, we basically compute the result for 2 or 3 particular incident angle or the polarizer angle. But actually what happened, if you have the intensity after the passing through the polarizer, so that's basically our angle, for example theta, And what you know that this it follows from like cos square theta, right? So the angular behavior is following. So this is still coming through and then coming back to 0, 0, and then coming through the maxima and then 0, something like that. So the minima is basically it's 0 when it has the 90 degree that we see, right? So the maxima is basically the 0 degree, and the again the next minima or the next 0 appear as like 270 degree, right? And this maxima is like 180 degree. So this is the eye intensity, this is the eye intensity, and this is the angle. So this is the angular behavior that follows from the Melas law, right? Melas's law. Very good.